You know, the results that we saw for inscribed angles actually carry over, can be extended a little bit further. And I want to share that with you right now. Here's an angle, the angle B, that's actually made not as an angle made up of two chords, but as an angle made up of, well, part of a chord and then a tangent line. So this line is tangent to the circle. So this angle here is actually generated by the intersection of this tangent line and this line that's actually a chord and that's extended outward. The really cool thing is that the results we saw for the other angles, the angles between two chords, actually carry over here. In particular, if you want to know the measure of this angle, it's going to equal half of the measure of this arc. So in fact, the results that we were looking at with respect to the angle between two chords actually holds when you're looking at the angle between a chord and a tangent line. So for example, if we look at this issue, so here we're given lots of stuff. I'm told that in fact this is, first of all, this is a tangent line. I'm told this is a tangent line, it's tangent, and that the angle made by this chord and the tangent line is in fact 90 degrees. It's a right angle. I'm also told that this arc here has a measure of 40 degrees. And here's our mission. Our mission is to see if we can find the measure of angle PQR. That's the first mission. Well, that's actually really easy given what we just noticed. All we've got to do to find the angle is take half of the measure of this arc. And so half of 40 is 20, and so I immediately see that this angle right here is 20, which was the first question that we were asked. 20 degrees. And now the second question I want us to think about is, what's the measure of the arc SRQ? SRQ. So way over here. Now how are we going to find that? Well, look, notice that here I see that we have a right angle. So I know this angle is 90 degrees. This is a tangent line, this is a chord, and so what I see here is that this angle has to be half of the measure of this arc. Well, so therefore, since this is 90 degrees, this arc has to be double that, which is 180 degrees. And so I see that the measure of SRQ is equal to 180 degrees. Which, by the way, tells me, this is not even part of the question, but it actually tells me that this chord is actually a very special chord. You know what kind of chord this is? This has got to be actually a diameter. So it has to actually pass through the very center, because we have 180 degrees here. We know we have 180 degrees here. This is cutting the circle right in half. Now, we didn't know that, and we weren't asked that, but you can imagine a great follow-up question is, what can you conclude about the chord SQ? The answer would be, it actually is a diameter. Cool. So you can see that we can carry results over from angles between two chords to now angles between a chord and a tangent line. Very nice.